Hi guys, postman's bin, just an envelope with a little line of something in it. I know exactly what it is, which is what I've written on the outside there. From eBay, cost me £1.59, 150 ohm resistors, surface mount type 0805. And look, I'm actually using my letter opener for the purpose it's designed for. Don't do that very often. We got in there. There we are. What did I buy them for? To see if we can fix the circuit board for this, because the resistors that were on there just fell off the board when I tried to measure their resistance, and the actual tracks on there, the copper tracks, are degraded, so we're gonna have fun trying to solder them on there. But I thought I might give it a try, being as they're so cheap to get hold of. So we'll give it a go, but not just now, because the noise in the background is my tea is ready. Right, we're gonna have a go at this. I'll be honest, right from the start, I'm expecting a 0 success rate. Not just because these are SMD resistors and they're tiny, but also this problem with actually getting any solder onto any of the surfaces. We'll have to be extremely lucky, I think. I'm scraping off the green enamel, I think it is, to try and get some surface that we can try and get some solder onto. I'm going to go with this USB soldering iron, which has worked for me in the past. Right, let's see if we can get any. I did get a little bit on there the other day. Doesn't look good. I'm not convinced. I think I should have measured the resistance of these before we got going. I'm looking at the label on there and that doesn't look like the right values to me. Well, they are right. You can't see the meter, I can. And that's coming in right. Now for the real fun. Can we get one of these out of there and into where I want it? Are you going to lift up? Oh, you are lifting up. Right, chances of that, well, stop moaning and have a go, Grandad. I think everybody's got the message that I'm not confident. Might be able to get directly onto one leg of the transistor. Might. Nope, that doesn't look like that's going to take either. Oh, wait a minute. It might look a total mess, but there's a certain amount of method in my madness. Right, this probably won't seem like much, but if I press the on button, we have actually got current flowing through that resistor. It looks awful the way that I've soldered it in place. This resistor we're talking about, just here, 150 ohms. The reason it looks awful is I've had to bridge the corroded areas. So I've actually managed to make contact, and that is now working. What we don't have is the LED coming on. Right. I've got my new resistor soldered in place. It looks awful the way it's soldered off at an angle, but that's because I've had to bridge the gaps over the corroded track. So I wave that pin around, it's actually attracting the magnet on the flame. So let's let that settle down. Okay, so flame is stationary. Use the remote, switch it on, and away we go. But we don't get the LED come on. Switch it off again. That is slowing down. Okay, switch it on again, and away we go. So that part I appear to have fixed by replacing that resistor and soldering it in place. The previous one, when I tried to do anything with it, it just pinged off the board, so I think there'd been corrosion that got underneath it. Replacing that other one doesn't appear to have got the LED working. I have found that if I short across from the end of that resistor to the back end of that transistor, don't know if we can see there's a transistor there, just a little one, that turns the transistor on and that lights the LED. So does that help us knowing that? Not really. Clearly the positive, which is this white wire, is going onto the circuit board and going far enough to make the coil work. So there's nothing wrong with it between where it's terminated on the board and where it gets into the circuitry. If I just track it, it goes from there. Oh, it goes direct to there, so it's not going through there. I wonder if it's something to do with that capacitor that we were talking about. Oh no, the capacitor's just across. That's me blowing on that, sorry. The capacitor's just straight across the positive and negative. And the blob is obviously sending a pulse around here to operate the coil, which is why it makes the flame wobble around. If we apply a signal to that transistor, it turns on, and that is bringing the power to the LED. So the LED circuit's okay. So it would appear to be whatever comes out of the black blob is not sending a signal to the back end of that transistor, back end, to the trigger. I know that's the wrong word, but that's the effect. It's triggering the transistor, turning it on. If I do that, that's turning it on. So I think we've moved a step forward, but not all the way. Because turning that on should be turning that transistor on, and it's not. Oh, see what's happened there? I've just touched that transistor and it's loose on the board. Oh dear. That means I've got to do the same as I've done with the resistors, try and get it to make contact. All right, well, that's shown us something anyway. Right, that's the transistor, a 2TY. That'll do for today, and we'll have another look another day. Thanks for watching. If you want more information, check down below in the video description. If you like this video, you might like this one up here. And if you want to subscribe, you can check out my channel over here. Up here is my latest video on my channel, and down here is a video playlist associated with the video you've just watched. Thanks again for watching.